pencils out because you're going to need to take some notes today. You should put today's date at the top of your notes, and you should put investigation 7. Investigation 7. And then the coordinate plane. So I'm going to go ahead and write on this screen coordinate plane. So we're going to be doing some geometry today. Now, I'm going to hand out your own coordinate plane. So everybody is going to get 2 sheets, please. 2 sheets. And you can see that there is what we call an axis that is horizontal, and there's also an axis that is vertical. What's the difference between horizontal and vertical? Anna, tell me.
Vertical is up and down, and horizontal is side to side.
That's very good. Yes, that's exactly right. One of the ways that we can remember that, by the way, is horizontal goes with the horizon, right? Yeah, and that's an easy way to help you remember. And now this sheet is what we're going to be working with first, and it says coordinate plane on it too, and it's already got some points graphed. And we just need one of these. Now, for our notes, we're going to go over some pretty important parts of the coordinate plane. Now, anybody remember which axis the horizontal one is? Do you remember?
The x-axis.
The x-axis, yes. And that means the vertical has to be our y. How do I plot points on this thing? Has anybody done that before? How do I do it?
You need to first put like the numbers, the negative numbers and the positive numbers.
Okay, so I can have negative or positive, and that's true.
And then
How do I know where they are? Not sure. Okay, let's figure this out. Now, for a minute, I want you to pretend that this vertical is not here at all. Okay? And I'm going to put this point right here is called the origin. And this point is at 0, 0. Now that's called an ordered pair, so that's a good thing to write down in your notes. Ordered pair means that that's going to tell you what the horizontal direction and the vertical direction is of the points that we're going to plot. Now, let's make some sense out of that. The first coordinate, and that's what we call it, the coordinate inside the parentheses is our x-coordinate. And the x-coordinate, again, pretend this one's not here, it's going to tell us left or right direction. Okay, so this is like the number line that we were working with last week, right? Do you remember? So this is the same thing as a number line. Now, let's bring the y back in. This one too is a number line. It's just a vertical number line. So what that means is our positive numbers are going this way, and our negative numbers are less than 0. Remember, this point right here is 0, and then we're going to have -1, -2, and so on. So this is the same number line we were working with last week, only now it's got a grid on it. This one, the y-axis, also has positives and negatives. Where, Offensive, where do you think the positives are on this one? Going up. Very good. That's right. So every pink line, we're going to put numbers going up. So remember, 0 is right in the center where both of the axes intersect. So we're going to go 1, 2, 3, the same space apart using those pink lines. Pink lines. Now, what about the negatives on the y-axis? Where are those? Tell me.
They go down.
They go down. So what's this one going to be? -1. Yeah, we say -1, -2, and so on. Now, very good. So this, you can see that this is kind of like a vertical number line, right? Where positive numbers from 0 go up, negatives go down. So, coming over here, we would put our y-coordinate second. So this is called an ordered pair, and it's going to be x comma y, always enclosed in parentheses, x coordinate always first, y coordinate always second, and you can remember that because it's in alphabetical order. And the x tells you left, right movement. So what's the y going to tell us? Up, down. Very good. So the y is going to tell us up or down. So if I have numbers in here, that's going to tell me how I count from the origin. Okay? So if, for example, I had the ordered pair 2, 1. Okay? What that means is I'm going to count over 2 from the origin on my x-axis first, because the 2 stands for my x-coordinate, and that's going to tell me left, right. So I'm going to go to +2, and here I am on +2, and then my y-coordinate says go up 1. So I'm going to go over 2, up 1, and there's my point. 2, 1. Does that make sense?
Yes.
Anybody have any questions? Okay. Now the other thing we need to know about the coordinate plane is that it has something called quadrants. A quadrant represents a certain fractional part of the coordinate plane. When you think of the word quad, what number do you think of? 4. That's right. So it's the quadrants are going to be dividing this coordinate plane into fourths. And we always start here and go around counterclockwise, and they always do Roman numerals, I'm not sure why. But quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, everybody with me so far?
Yes.
Okay. And our timing keeps going off on this. But we can handle it. All right. Now, if we're going to plot points that have two positive numbers, a positive x and a positive y coordinate, Diego, tell me which quadrant those points would be plotted in. If I have a positive x and a positive y, where would I find all the points? Which quadrant?
I think in 1.
Quadrant 1, is he right?
Yes.
He is right, that's right. Very good, and this was an example, wasn't it? So we know that when we have a positive x, we're going to move in this direction from our 0, right? And then if the y is positive, we're going to go up. So we're always going to end up in quadrant 1. Now, what if I have two negatives? What if I have a negative x and a negative y? Rubens, tell me.
You find them in 3?
Quadrant 3, are you sure? Is he right?
Yes.
Yes, he is. Because, here's the origin, again, our x would tell us to go back this time, where our negative numbers are, and then our y coordinate would tell us to go down. Very good. So, quadrant 3. Now, what would the points look like, Chesky, if they showed up in quadrant 2?
It would be, it would be the negative number first and then the positive number.
Right. Now, can you repeat that using my x and y?
Okay, so for example, like you put a point where there's 1 and 1, negative 1 and positive 1. You have to
Okay.
put the
So you're saying, I think you're saying that it would be like negative 1, positive 1, like that? Is that what you mean?
yeah, because you always put the x in the middle.
Very good. So I would graph that by going back 1, and then what do I do for my y? Up 1, right. Back 1, up 1. So it would be right here, negative 1, 1. Does that make sense? Okay, so Arthur, what about quadrant 4? What would our points look like? What would our ordered pair look like if they're down here?
It would be positive number
Which one would be positive?
x,
X would be positive, okay, so it would come this way, and then what?
and then a negative number and y.
Very good, perfect. So then we'd go over and down. Everybody understand? Okay. Now, let's look at our papers that I gave you. And we have just gone over everything on that first page. Now, the one thing I want you to notice is that they have plotted certain points there, right? They have plotted a negative 3, 2, a 3, 2, a negative 3, negative 2, and a 3, negative 2. Now, if we were to connect those points with line segments, what would our polygon look like? Lucas? It would be a rectangle. That's very good. What would our length and width be in number of units? So what I'd like you to do is connect your points, and we're going to see if we can do some geometry with this. So we have a rectangle, and we want to know length and width. Now the reason that we want to know length and width is because we want to be able to figure out our perimeter and our area. Rafaela, do you remember what perimeter is?
Yeah.
Tell me.
Perimeter is like you find out what like let's pretend I have a square
Okay.
and on each side I have like 4 centimeters, and then I add I do 4 times 4 because the square has 4 sides, and the perimeter is when you add the number of the edges.
Right, the
Yeah.
distance around or the
Yeah.
length of each side, right? Now she's talking about a square, right? So all the sides would be the same measure, right? Is she right in saying that you'd have to add them all up?
Yes.
That's right, because perimeter, that's what it means. Ancient Greek, it actually means the measure around. How many of you have seen a movie where you saw a periscope, a submarine, with a periscope, right? They lift the periscope up, and then the guy looks and he turns around like this, 360 degrees, and he can see, yeah. So he can see all the way around, 360 degrees in a circle, we talked about, right? So that's kind of what's going on. So perimeter means the distance going all the way around. So I'd like you to tell me, what is the perimeter of this rectangle that you've drawn? I'm going to draw mine too. Everybody have an answer?
Yes.
Okay, so how many units is my length? How many units is my length? Jasmine?
20.
Okay, listen to my question. How many units is my length? Okay, so what's length represent in a rectangle?
The bottom, like the long.
The longest side, that's right. So this is a length measurement, right? And where's my other length measurement? On top, very good. So this is my length. Now let me ask the question again. How many units is my length?
Well, 6 each. 6 each, but together.
Okay, so you're saying 6, that this is 6 and this is 6, right? Is she right?
Yes.
Okay, so let's add them up. So again, we're looking at the pink lines. So we went back 3 units, so we know we have 3 here. And then we went up 3 units also. So we have 3 here. So our length is equal to 6. Right? Everybody got that? What's our width? Lucas?
4.
He says 4. Is he right?
Yes.
Okay. So same thing. We went down 2. We went up 2 from the axis. So our width is equal to 4. Every rectangle in the universe, length is the longest side, width is the shortest side. That's how you know, okay? So our perimeter, we have to add them all up, Hafeala said, and what did you get for your answer?
I didn't do it.
You didn't do it yet? Okay, well let's do it together.
Okay.
Okay, so what numbers do I have to add up?
6 and 4.
Okay, so I'm going to add a length, and then I'm going to add a width, and then I'm going to add, that's all? Okay, so I added up 2 sides?
Oh, no. You have to add all the sides.
Yes. And it has how many sides?
You have 2, no, 4.
4 sides. So what do I need to add in here?
4? No. 4? Yeah, 4.
Another 4, okay, because I have 2 widths, right? And then what's the last number I'm going to add in?
6.
Another 6. Now, I might have done this in a little bit different order, but it's okay. So what you can do is just use your finger and go around. I'm going to have a 6 plus a 4 plus a 6 plus a 4, or I'm going to have 2 lengths and 2 widths. But in any case, and notice I'm using my formula here, I've got 10 plus 10, right? Again, look for shortcuts when you're adding. And it's always easier to add 10s together. Okay, so I've got 20 units. Very good. Now, what about area? How do I do area? Offensi, do you remember that formula?
The area is the area inside of the shape.
He said it's inside of the shape. Is he right?
Yeah.
Yeah, very good. So area represents coverage, okay, where perimeter goes around like I'm fencing it, okay? So like this is my ranch in Arizona and I'm fencing it to keep the cows out, which I definitely need to do. So I've got a fence, but if I want to plant grass meters, which I don't think I should do, that's super expensive, but that would be coverage, right? So what formula do I use for finding area, Carmina?
Multiply.
Multiply what?
Multiply 6 by 4.
Is she right?
Yes.
So we're going to take length times width. That's what it looks like in geometry. And just so you know, when you get to geometry with Mr. Mecklin, if he says, what's the formula for area? What are you going to tell him? No. You have to say area is equal to length times width. In other words, we don't leave that out. That is not a whole formula, okay? So in order to give the whole formula, you have to include area is equal to. So area is equal to, now I'm going to put my length in, which is 6, and my width is 4. Why am I using parentheses? Yes?
Because it's the algebra way to write, right?
It's the algebra way, yes, because we're big kids now, right? So why don't I do this? What's wrong with that? I learned that downstairs, right, in the lower school. What's wrong with that?
Because in algebra you use x is like 6 times x equals something. So it's like a replacement for that.
That's right. That's called a variable. You're so smart. So this x gets used all the time as a variable. So if we use that to mean multiplication, it can be confusing. So we don't do that now that we're big kids. Okay, so it's 6 times 4, and when there is no sign in between the parentheses, that means to multiply. So what's our area, Anna? 24 what? Square units. 24 square units. What exponent could I use to mean square units? Emily? A little 2. Where would I put it? Tell me. Here. So how would I do it? I want you to write again. Area is equal to, and label it using an exponent this time. Perfect. Very good. Now notice that she put the exponent after the word units and not after the 24. Because that would mean take two 24s and multiply them together, right? So that would mean 24 times 24 would be the answer, and we don't do that. So make sure that you always do it the way you did it. Very good. Okay. Let's take a short break. Minutes. Okay, let's go.